Hey guys, hope you're all doing good. In this video, I'm going to be telling you how you can actually change this valve lift automatically using the parametric study option in the flow simulation toolbox. So the first thing you need to make sure that you do is you add the dimension, which basically controls the valve lift. You can take a look at the previous video if you do not know this. Once I've done this, what I'm going to do is, without exiting the smart dimensions, you can actually go to the flow simulation toolbox. And then make sure that you've already run a baseline simulation. Now running a baseline simulation should be something that's very easy. So let me kind of delete my existing parametric study first, and I'll just kind of tell you what I did. I basically just have an inlet. I basically have a total pressure inlet and a static outlet, and that's basically it. And once I did that, I got my simulation. So once I've done that, what I can actually do is I can right click on my flow analysis, and then what I can do is I can click on new parametric study. And when I do that, you will see that you can add the dimension parameter. And what I can do is I can just select my dimension here, which is basically my valve lift. And if I hit accept, you can see that there are several options here. So just click on this discrete values. And what I'm going to do is I'm going to basically select range with number. So here the idea is I can provide a minimum lift, which is 0.001, and I can provide a maximum lift, which can be something like 0.008, and the number of values that I need in between, let us say that I want 7 values. All right, and let's just click OK here. So that way our geometric study has been set up. The next thing that I want to do is I want to add output variables. Now in this case, the output variables refers to either your goals, or it could be results that you want. So the first thing that I want to do is I want to add some results. So what I'm going to do is I'm just going to have this cut plane here. Let me just delete it and redo it so that you get an idea of how I did that. Let's just delete it and click on cut plane and then click on insert. So when you do that, it's basically going to ask which plane you're going to use. So we are basically cutting the geometry using the front plane, which is perfectly fine. And I'm going to be, say, looking at the velocity. Oops, not the vorticity, but the velocity right there. And let's just click OK. And this is one of the things that I want. And what else do I need? Well, I'm also going to be looking at the mass flow rate through the outlet. So let me just delete this guy and tell you how I did this. So I'm going to right click on goals, and I'm going to click on surface goals. And what I'm going to do is I'm just going to select mass flow rate, which is right there. And I'm just going to right click, click on select other, and not this option, but just give me a second. Select other. For some reason, the lid is not being displayed. So let me just close this guy and make sure that I'm able to select this. Let me go to my flow simulation box and alright, so let me try that again. So to add, alright, so then what I'm going to do is I'm going to basically, alright, so what I'm going to do is I'm going to right click and add insert surface goals, and what I'm going to do is select mass flow rate and right click, select other, and I need to select the lid option, click OK. So now I can come back to my output parameters in my parametric study, and for goals I can add the surface goal mass flow rate. And for results, what I'm going to do is I'm just going to select this cut plot, which is velocity magnitude. Let's click OK. As far as the mesh, let's just edit definition. We're just going to run it on a scale of 4. You can look at the basic mesh if you want to, or if you don't want to do it, that's fine. Go to the scenario, make sure that everything is all set up. Now you can see that all of our design points are here, and all we need to do is just click on this run button, and we just have to wait for the simulations to complete. So now that the simulation is running, one thing that you might find interesting is if you apply some amount of transparency and zoom in near the valve, you will see that after the design calculations are complete, the valve will automatically be pushed open a little bit more. So this is really convenient. You don't have to do it manually. You can do it manually if it is just a few cases, but since we are trying out a lot of cases here, it would be great if all of these changes happen automatically. And that's exactly what's going on here, so that saves us a lot of time. Alright, I'm just going to check back on the simulation later to analyze the results. Okay, so looks like the results are complete. So the first thing is, when I look at the cut plane, you can see that, so initially when the valve lift is close to 1 millimeters, the velocities are really low, but then when the valve opens, you can see that there's a really high velocity and the mass flow rate also increases. Oh, alright, and I'm just noticing that I actually forgot to add my goal values. So let me just add the mass flow rate. I thought I added it. So let me go back to scenario and let me see if I can just refresh this, and so looks like the mass flow rate result did not get calculated. So I'll have to run the simulation again. So let me just click on run again, and once I get the results for the mass flow rate, I'll be back. Okay, so looks like the simulation is done, and you can see that for the different design points I'm getting the mass flow rate. I should be able to export this into Microsoft Excel and I can plot it, and if I have experimental data I can compare, or I can and I can also go back to chart view and I can quickly look at how the mass flow rate changes. Now remember, in this case mass flow rate is negative, so whenever the mass leaves the domain, it's treated as negative. So that's fine, you don't have to worry too much about it. You can just take the absolute value of this number and you can use that. Now this type of plots are really useful. There are a lot of reduced dimensional solvers like GTPower where they actually use this particular data. Now this data can be obtained either from CFD simulations or from experiments, and having this mass flow rate versus lift data can be used to tune the performance of reduced models like GTPower, so that you can get really accurate results. Okay, so this is all you need to finish your project. I hope the video was self-explanatory. Alright, I hope the video gave you all the information that you were looking for. Good luck with your project. Bye. I hope with this information you will be able to complete your project. Thanks. Bye.